Hello, everybody. Welcome to IST 140. I'm, of course, Professor S. This is today's lecture. So, what we're going to do today is we're going to talk about what's due for modules 1 and 2. We'll talk about scanners. I'll go through a little bit of a walkthrough using the scanners. And then in class, we did practice problems. And as I discussed before, we're not going to do those practice problems in the recordings. That's for like people that want the help in the class. So if you want this additional work, remember to make sure you come to class to get this additional help. All right, so now we're going to talk about what's due. All right, so to kind of help understand what's going on with these different assignments, I color-coded everything and have the due date. So before class on Monday, you need to have the Zybooks done. So for both chapters 1 and 2, and that's in Canvas, that's there. Also in Canvas is before the next Monday is all the programs and the concept quizzes, right? And so the programs, they're for the first two, or for the Zylabs for chapter 1, there's like 4 of them that go into 2 different assignments for some weird reason. And then in chapter 2, and there's also a flowchart that you have to do. And then there's another Zylab, another 2 Zylabs, a programming assignment that you do in module 2 that's due before class for not week 3, but week 4. That's when Monday, the 3rd of February is. Okay. And then during week 3, on that Wednesday, on 129, is the graded programming quiz. Okay, and that is in class. Okay, and this is all in Canvas, and it should be easy to find that way. Now, a couple of things before I go back to the older recording, because this is, if you can't tell, this is shot at a different time. But anyways, there is practice quizzes at the time of this recording and the time of the posting of the recording for the practice quizzes for modules 1 and 2, but they will go away after Monday. So at the time that the Zybooks are due, that's when the practice quizzes, are going to be gone. You have, as long as they're open, you have as much time as you want on them. You should get feedback on your answers, and it's a good practice for the concept quizzes. They're kind of based off of the reading. Let's see. Another thing is honor lock on the quizzes. So on the concept quizzes, which is like the multiple choice that's available after class on Monday is when it pops up. You have until like the week to pretty much do them. Make sure you give yourself enough time to do them. Make sure it's in a quiet place and it gives you enough time to work on them. For both the concept quiz and the programming quiz, that is using HonorLock. So make sure you have both Chrome and the HonorLock extension installed on your computer. Make sure for the concept quizzes, you got to stay in your browser window, and that's what you're doing. For the programming quizzes, you can it's similar as the concept quizzes, but like I said, it'll be in class, and it will also use HonorLock, but it will allow you to use IntelliJ in class to do that programming. And just like any other programming thing, the program must match your recording, and not supposed to use generative AI. And you have to be in person to take that quiz. If you're not in person, if you're not in the classroom taking it, and you take it outside of the classroom, then you will get a 0 on the quiz. So that's in the syllabus. Anyways, all right, yeah, so that's the quizzes. The one other thing to talk about is the programming rubric. So there's 2 programs that you're doing that will be using this rubric. The other ones, like in module 1, there's some like programming assignments. One is a flow chart, and the other are Zylabs. Those are pretty self-explanatory. There's no rubric that goes with the Zylabs. but you get your first program. And so you're going to do that in IntelliJ, and you're going to follow the directions, but you're also going to make sure you follow these. This is like the rubric that you'll be graded on, and I'll talk about each one of these points. So first of all, programming execution. That means that the program runs without mistakes, and you're not using programming techniques that we haven't talked about, right? So the idea is like when we're using concepts that we're not talking about yet, it looks kind of suspicious. So we're just taking off points when you're not following that direction. See, the thing is that like there's going to be times when the programs, it's definitely going to be easier to use something that we haven't talked about yet. Like if you have to redo things over, and like you have to prompt a user the same question like so many times, totally easier to use a loop. I get it. That's kind of why I'm doing it. The idea why I'm doing this is not for cruel and unusual punishment. The idea is to get that need for learning that new concept. And so if you just skip to just like, this is how you do it, you don't really learn as well as why it's useful. Because it's like one of those things, you don't know how much you miss something until it's gone. Well, the idea is like you don't know how much you need it until you've tried doing it without it. Hopefully that makes sense. Anyways, that's the way that we're going to be doing things with the program execution. And so that's where we'll take off points when you're doing things that we haven't covered. That includes, for at least Module 2, doing loops, if statements, switch statements, creating methods, creating classes and objects. I mean, like the object you'll create is a scanner object. And that's pretty much it. Like you shouldn't be using arrays, array lists, any other things like that. So really, I just want to see you use scanner, and that's how you should be getting your input. Okay. Just use concepts that we've talked about in class. Kind of a big part of what we're teaching you is how to problem solve with the tools you're presented with. Okay. Anyways, the next thing is the program documentation. Make sure you include a synopsis at the very beginning, couple of words that say, this is what the program does. It doesn't have to be very long at all. I don't want you copying and pasting the directions, just a few words about what's going on. Very lenient as to what it is. It's kind of, it's pretty self-explanatory. Don't copy and paste the directions, just summarize it real quick. It doesn't have to be that long. Not looking for a page, just like a sentence or two. Okay. Let's see. Make sure you also include comments. Comment correctly. I don't want to see a comment for every single line of code, but I also want to make sure I see comments in your code. So somewhere in between those directions of no comments and too many comments is a healthy level of comments. What that is something that you kind of learn to do as you go along. So what I'm just trying to get you to do is comments. I'm pretty lenient with what counts as comments and stuff like that. But the idea is like commenting is the intent of commenting is to make it readable for code. So or make your code easier to follow so that somebody can look at your code and know what you're trying to do or what you're trying, very easily. So it's a good habit that since this is about learning how to program, working on building that habit. So make sure you use comments correctly. Let's see. Next one is programming style. Make sure you use meaningful names for variables, and make sure you indentation. Indentation is going to be a much bigger thing as we go along because it's like helps with the structure of it, thinking about loops and different things like that. It's not as big right now, but it will be, and that's where points will be taken off with the documentation. The output format, this is kind of a lot of where the assignment points get taken off. The assignments are going to be looking for specific things, and your program should be doing that, right? It's going to say like find the sum of these numbers, so it should be output the sum of the numbers. So we'll be looking for the sum of those numbers in the output of your program. Okay. Kind of feel like that's cut and dry. The next one is test data. A I want to make sure I see some output of your data. So just copy and paste it from the, like running it a few times, like 2 or 3 times. Like the idea is like you're trying to test to make sure it does what it's supposed to. And so I want to see that you're testing it to do what it's supposed to. Okay. I might have directions as to different things that I'm looking for the test data. So make sure you keep your eyes open for that. Otherwise, if I don't, just do enough to kind of test to make sure it's doing what it's supposed to. And like depending as we get more complex, the more I might be looking for test data or stuff like that. The idea is like I'm looking for you testing your data, your code, making sure it works. Okay, it's all part of it. If you have questions about any of these, make sure you ask them. Okay. But anyways, that's the rubric that all the programming assignments that aren't Xylabs will be graded on for the rest of the semester. Okay. All right. Now let's get into the lecture of today's thing. All right. So anyways, what we're going to be doing is performing arithmetic in Java. There's a change types in Java, and we'll be using scanner. Some things that we'll be using is prompting, package, and mod, I guess, a little bit. We've already kind of covered mod, but we'll talk about that later. Remember, it's like when you have integer division, right? So like 5 divided by 2. There's 2 numbers that you kind of get for that, right? You get the quotient and the remainder, especially when you're doing long division, right? And so what mod does is it says when you divide 5 by 2, what is the remainder? That is the mod, okay? It might seem like an inconsequential thing that we might care about, but it's a very useful tool in programming, and it's used a lot in cryptography. Yeah. Anyways, we've kind of talked about this in the last class where we talked about different ways that you can add stuff and store it. So if you notice, like for instance, this value right here. So say we have a counter of a value, and we want to add 1 to it and store that as counter. This is how we would do it normally. But an easier way to do it would just be counter plus plus. And the nice thing about this method is that, or this way, is that it just like it reads real quick. You're just adding 1 to it and storing it, and that's it. Just like then we have the -1, and you could do minus minus, and that's a thing too. There's other kind of versions of this too. I think the book talks about it. It'll be more apparent when we get to the loops. But as far as this is just what we're going to be talking about right now. Then we have counter plus num. So the idea is sometimes you want to add more than just 1 to the value. Sometimes you want to do 2 or something like that, or maybe it's a changing number. And so then that's what this does. So this adds num to counter and then stores that sum to counter. Same with this. It except it's not add, it's multiply. So multiplies num to counter and stores it as counter. So it's doing the exact same thing as this line right here. Okay. Now, there is other arithmetic. Here's some common things. Notice that they all start with math dot something. Couple of things. There's a few of them that we're not going to really use that I don't remember using that much when teaching this. We do have the square root and the pow, because you can't just use the caret sign. It doesn't work that way. You have to use the math.pow for powers. That's pow is short for power. Let's see. Then we have the exp is not exponent. Well, it is exponent, but it's the exponent of e. So you just put in the x and it's gives that exponents. We have the natural log here, and then log base 10. Round, that's something that we'll use. Something that you should know is that the returning value is a long value. So it's an integer, so it rounds to the nearest integer, but it's not an int. It's a long is what it's called. Okay, we'll see that in just when I do the walkthrough. Okay, then we have absolute value, and we won't really be using these too much because we'll be using we'll be doing comparing with greater than and less than and stuff like that. But that's a thing too. Yeah, I think that's good. Let's see. Oh, so you know how we have with the rounding that the it doesn't store like the math dot round doesn't return a int. It's an integer, but it's not an int. It's a long. So what we can do is a thing called casting, where we say, all right, this integer we want to store it as an int instead of a long, and that's when you put it in parentheses the data type that you want to store it to, and then it changes it to that data type. Okay, I'll show you what that is, and when we get into the example in just a second. Before I do, I want to talk about like how this whole scanner thing works. It's going to be another one of those things where it's just like, just go with it now, and it'll make sense later. Okay, so the idea is that first of all, you know how we have the print function that prints stuff onto the screen, and that's native to Java. Well, there's not really a way to input user input native into Java. What we have to do is we have to load a package and then create a scanner object and use that scanner object. And again, it's going to be like, well, why can't we just do it? There's some reasons for it. I don't really want to get into it because I think trying to explain it's going to make things more confusing than if you just go for it now, and we'll kind of explain it as we go through this semester, and you'll see why we don't. But anyway, some words. So first of all, prompting. So when we're prompting a user for values, what we're doing is a two-part thing. It's an input-output sort of thing. So first of all, prompting means that you're requesting information from the user, and then you're reading their response. So two parts: output, what you want; read, what they give you. And so the tool that we're using for reading will be the scanner object. And in order to do that, we need to import the scanner package. I'll show you how to do that in a second. And then you also need to create that scanner object. Okay. A package, just so you know, is like installing packages, loading packages, importing packages, whatever, is a very common practice in programming. It's like in most all the programming languages I've used, there's been a package element where the language itself can't do everything, and so you need added functions to it. In this case, scanner is one of them. Okay, for Java. So anyways, though, in order to work this, notice that first of all, we import java.utilscanner. There's nothing for you to download. It's just like you put this outside of the public class that you're working on, and you can start using it. And by using it, you can create a scanner object. That's what it is. So you can create the object and use it. That's what this whole import function allows you to do. Okay. So once you import it, then you need to create it in order to use it. Can't use something that you haven't created. So I guess kind of like a way to think about this, think about like creating Word documents. Okay. So say you want to, I don't know, do a Word document. So first thing you need to do, open Word, right? So in order to open Word, like that's in order to actually have a document, you need to open up Word. That's what the import does. In order to create a scanner object, you need to import it. And then in order to actually do something with a document, you need to create it, right? So it's like a new file. And so that's kind of what the scanner is in order for you to use scanner, that it's technically a class. In order for you to use the scanner class, you have to create a scanner object. In order for you to use Word, you have to create a document, right? Just an analogy, but hopefully that helps make sense of things. So the idea is once you have that object, then you can start using it, right? Once you have a Word document, then you can start editing that document, right? All right. So anyways, this is a very rough program. So what happens here is we create a scanner object. This one's called in, and all scanner objects are created the same way, where you have the class, the object name equals new, the class name again, and then in parentheses system.in. That's it. Oh, and then the semicolon. That's every line. So really, when we're creating scanner objects in the first few weeks, this is eventually something we'll change, but it's going to be like just in, or just the name of the object. And so that could change. Like that could be read, that could be SCNR, that could be input. There's lots of different things that we could choose this to be. But once we can create the scanner object, we can use it however many times we want within our program. We don't have to keep on creating it for every time we want to get the user's input in that program. So once in that program that it's created, You're good. You don't have to keep on creating it unless you need to read something else. But like if we were going to, like for instance here, system.out print, please enter the number of bottles. And so then it stores bottles, which is an int, by reading what the user entered. Notice that we have in, which is our object here, and notice that it says next int. It's reading a integer. Okay. If we want to do this again, like if we want to say enter the number of cans or something like that, then we could just, if we're prompting the user for that, then we just say, please enter number of cans after this, and then int bottles n equals next int. We don't need to recreate another scanner object to read another thing that we're entering because it's all entered in the same location, the command line, once we run it. Okay. And then here we're printing that bottles. Anyways, I think it might be good if I just show you how to use some of these things. So let's go into IntelliJ and see this firsthand. Okay. All right. So now here I am in IntelliJ. I have just a project open that I have that I created, but I kind of want to go through the whole process just to refresh in case you missed how to do this. Because when I was walking through this with students before, they weren't putting programs in the right places or stuff like that. So anyways, the way that you do this is once you've created a project, see where this folder that says SRC, you're going to right click or double click, whatever the other than just the main click, and you go to new Java class. And this is where you're creating your thing. And so I'm going to do like week 2 WT. Now, when you're doing this, make sure that you do the like an upper camel case. So the first thing should be capitalized and there shouldn't be any spaces in here. And so make sure it's a class. Boom. Class, as far as we're concerned right now, is essentially a Java program. All right, so in order to, we're using the scanner, and remember, we need to import that thing. So remember, we have to load it first. So let's import it first. So it's import java.util.scanner, and then semicolon. And notice that it's gray because we haven't used it yet. And so we'll use that in just a second. But this loads it. Make sure you have the correct, this shouldn't be any different from yours. Make sure that this is a capital S and everything else is lowercase. Yeah, it should match that exactly. If you're having trouble with the scanner object, it's probably a typo in that line. All right, so anyways, let's create our main method. So public static void main. There's only a few things that could be different for how we do our main method, but really it should be matching this exactly. Main should be in yellow, and if it's not, there could be something wrong with how you created this program or something like that. But anyways, it should match this exactly. Notice that we have our braces here. So it opens here, it closes here, and then this program opens here and closes here. Okay. So anyways, I'm going to outline what I'm going to do, kind of help model using good habits. So we do this, we do create scanner object, and then we're going to prompt user for 2 numbers, and then we'll make calculation. Okay, so first the object. So the way that you create a scanner object, it's always like begin scanner, and then you have whatever you want to call the object, and then equals, and then new scanner system in, and then the semicolon. So this should be pretty much the same for any time you're creating a scanner object for the first few modules. Okay. And so anyways, I'm going to call this in is what I called it before. And so, or that's what I called it in the slides. I mean, I could do input to make it slightly different. Um, and then we're going to prompt the user for a int. We'll just start with an int. Okay. So, even though it says two numbers, we'll just start with one. So we'll do, we got to prompt them. So system out println and trying to type and so I like to having that little space so that when it prompts the user, there'll be a space after it, so it's just not all cramped up, right? Okay, so now we'll read whatever the user puts. So like, call this like user num1, right? Because it's the user number one. And then, okay, I'm getting ahead of myself. So we need to use our scanner object, which is input here. And then we use our scanner methods. So when you create a scanner object, you get some scanner methods that you can use with your method. We're going to talk about two in this this thing here. So first is like next int, which is what I had in the slides. Okay, so it's going to read a number and then it's going to do it here. And so then I want to find the square of it, right? So if I do system out println the square, or how about this? Calculation. Then we'll put in our number. So user num1 plus, add a space there so it has some room to breathe. Squared is, oh, and this is not making the calculation, this is printing a result. So actually, let's do print results as the last thing. So anyways, we need to make our calculation. So we want to do whatever the squared is. I'm going to call this S squared val, because it's squared value, I guess. And so we're going to do sqrd val. Oh, this is a int, right? Because we're going to be squaring an int. So int, we'll call this squared val, and this is going to be user num1 2, right? And so the we're going to give this a try, see what happens when we do this, right? Remember in the thing before, it said that it said that you had to do the power to do that. So we'll see what happens when we do this. Run. All right, there we go. Enter in a number. We'll do one that we know the square of is 3. 3 squared is 9, right? So I do enter, and it says, 3 squared is 1. See, the thing is, it's like the caret doesn't really mean the same thing when we're doing it. So in order to do squaring, there's two different things that we could do. We could do math.pow, or in this case, since it's squared, it's that number times that number. So typically, the way that people do this is they'll do user num1 times user num1. Let's do the power thing. So we'll do math dot pow, and we'll do user num is the base value, and user num1, excuse me, that's why I didn't like it. And we have we'll do 2. Notice that it says up here double, so it's going to automatically cast it. So but since it's looking for a double, to just kind of identify that I know that it's a double, I'm going to do this. And so let's see what it here's the problem, is that it's looking for an int, so it's going to output a double, so I want to keep this as a double. Okay. All right, so anyways, I don't know why this is still running off the top of my head, so let's run this. All I want to do 2, right? So it's going to square 2, so it should give us 4. So when we run it, so notice that it says 2 squared is 4. Great. Now, like I said before, maybe we want to prompt 2 numbers. And so maybe instead of doing a squared, we do a power. So I'll do this POW value, and we'll do, to match, it would be POW value. And we'll say the, let's see, that, how about to the power of user num2 is, and notice that it's red because that's not a variable that we've created yet, but we're going to be essentially prompting the user for a second number. Then call this user num2. And for the sake of it, I'm going to make this a double. Add a space in there to make it a little bit easier. And so notice that this is going to read an int, but if I want to read a double, like if I want to do like 2.5 or 0.5 even, it's not going to read it because this is looking for integers. So in order to read a double, watch this. We type in double. I know, right? So anyways, now, I mean, it's going to read a double, enter in a second number. Let's specify, enter in a double. So then the user knows what they're going to enter, and then we're going to do the POW double, and this is going to be user num2. Okay. So we have number 1, number 2, POW val. All right, let's see what happens here. So let's see, what's numbers that we know? How about, 2 to the power 3 is 8. So when we put in 2 and 3.0, it should be 8.0, right? All right, so 2, 3.0. And so then it says the calculation 2 to the power of 3.0 is 8.0. Great. How about, like, let's try rounding this. So instead of doing a double, we want to do this as a, we want this as an int. Actually, let's just keep it like this for now. So let's like round it. So then it is int do round POW val. And that's, remember, using math.round. Math.round. We put in our value, so POW val, and then store it. And so then is about, what do we call this? We call this RND POW val. Okay. Now the only problem is that this is, it's got this wiggly, this mark. So math round does an integer, returns an integer, but if you notice here, it says provided a long. So that means it's returning a long. It's a different type of integer than int. So you remember how with the floating points, like I said before, like we have floats and we have double. We don't really use floats because we have more space than we did when Java first came out. So we use doubles. There's other floating point numbers, just like there's other integers, like some take up more space than others. Long takes up more space than int do. But anyways, we want to change this into an int. So in order to do that, we have to cast. So the way that we do that is we put the data type that we want in here in parentheses right before it, and it will convert this, which is a long, into a int. Okay, so what this should be is, instead of 8.0, if we enter in 3.0, it should be just 8. So enter a number, 2, enter a double, 3.0. And then notice that the calculation 2 to the power of 3.0 is about 8. Okay? And I say about because we know we're going to be rounding to the nearest integer. So like, let's say we did, let's do another example. So if I do, my base is 100 and I want my double to be 0.5. Okay. So this is a power that's 1/2. What this is doing is finding the square root. Okay, we could use the square root function, but like this is just finding powers. And I just realized that I misspelled calculation. Let's just get rid of that. Sorry, I'm just in it. All right, there we go. It took way too long to find. Oh, and I just ended my program. All right, let's start it over again. All right, so enter number, let's see, 100, and we're going to find the square root. So we're going to do 0.5. And so remember, the square root of 100 is 10, right? So it should give us 10 as our answer, right? So 100 to the power of 10 is about 10. Awesome, right? All right, so it did it. Now, let's kind of test the rounding of like something that we know would be a decimal. Okay, so 10, so just bear with me real quick. 10 squared is 100, and 11 squared is 121, right? So if we have any number between, let's see, if we're thinking about so any number between 1 and 121, the square root will be either closer to 10 or closer to 11. Okay, so let's try that out with this. So like, for instance, if I do enter a number, we'll do 101, right? Or let's do 110. Why not? And then enter in a double. We'll do 0.5. Okay, and so this should be either 11 or 10 because it's going to be rounding, because that's what we told it to do, was to round. And notice that it does round to be about 10. If we want to know what it actually was, here we could just say is, we put in the POW value. I think I have an extra space in there. Okay, so we'll have 110 was our value, right? So 110 and then 0.5. And notice now it gives us this long decimal. Now, really long decimals aren't really something that you should be trusting with doubles. We'll kind of talk about that later, but yeah, that's how you do it. Anyways, I think that is good for today. Hopefully this made sense to you. Practice with the stuff that I did, and we'll see you all Monday. Bye. Hey everyone, hope you enjoyed that video. If you did, please press the like button below. It lets me know I'm doing something right. If you have any questions about any of the content, please send a message to both me and the rest of the teaching team in Canvas, and we will get back to you as soon as possible. Don't send it through normal email. You will not get as fast response. If you have any suggestions for how I can make these videos better, please leave in the comments below. Don't forget to roundhouse kick the subscribe button and ring the bell to get notified for the next video. Anyways, I think that's good for now. See y'all later. Bye.